This lecture is a continuation of the lecture on measurement systems, and in this lecture we're going to talk about how measurement systems relate to quality assurance. So when talking about quality assurance, measurement directly affects the quality of a product, and the quality control is needed to assure the meeting of set standards. And as quality control must use some kind of measurement to identify that level of quality has been established. So that's where measurement and quality assurance come together, because in order to identify the quality of a product, we typically have to use some kind of measurement to identify that it meets that level of quality. So for example, if we're looking at the thickness of a particular part, in order for that to meet a certain quality standard, let's say it has to be a 1/4 inch thick. Well, if that material or that product only happens to be an 1/8 inch thick, then we would say that it doesn't meet the quality standard that is needed for that particular part. So that's where the measurement and quality assurance come in together. And many times when we look at a particular measurement or looking at the quality control of a product, we incorporate some kind of tolerance. And tolerance is essentially the variation that is allowed in order for that particular product to meet the standard needed. And tolerances are important, especially when it comes to identifying very exact measurements. And so let's say, for example, if we're machining a part for an engine or a transmission, that those parts have to be very, very accurate. But to create a part, to machine a part to the exact, let's say even if it's down to 1/1000th of an inch, to create that on one specific 1/1000th of an inch every single time is really not feasible. In some cases almost impossible for a manufacturing company to do. And so that's why there's a level of tolerance for a particular part that communicates how much variation we can have. So as you can see here in this image here, we have a hole, and it's telling us here that we have a diameter of 0.503 to 0.500. So essentially it's telling us that we have 0.003 of an inch of variation that is allowable to fit within that tolerance. So if we were to drill that hole and it ended up at 0.504, then we would be outside that tolerance and that wouldn't be acceptable. However, on the other hand, anything within that range would be acceptable. And tolerances are important because, again, as I said, it allows that variation. When it comes to producing very exact parts and components, there's going to be some level of variation. That variation may come from the material itself. That variation can come that when a material heats up and cools down, there can be differences. That variation can come from the sharpness of a blade. So the smaller the tolerance, or the more accurate a part needs to be, the more expensive it is for that particular company to produce that part. So if that part has to be an exact certain size, then the company is going to have to put procedures in place to make sure that it's that exact way every time. So that may mean we have to sharpen the bit every single time. And that's really not that feasible. And so that's why we have different tolerances to allow the company to produce parts over and over again while still fitting within a specific range that it needs to be. So with quality assurance, we want to use the systems model, whereas if you'll recall, the systems model includes inputs, processes, and outputs. And it's important to look at quality assurance at each one of these stages. So for example, let's take that example of a lumber mill, which we had used earlier, and that we want to do some quality assurance at each one of those stages. So if our input is the raw logs that are coming down the river, that we pull out of the river, and we are going to put into the mill, we want to do a level of quality assurance on those raw logs. And so that if we find a log that is really warped and really crooked, we don't want to try to put that through our mill because that can cause some problems. So we're going to set that one aside. So there's a level of assurance that goes into the input. In terms of the processing, let's say for example if we are cutting that log, we're cutting it to a particular thickness. Let's say we're cutting a 2x4, and so we're going to cut that to 1.5 inches thick, that we're going to have some quality assurance throughout the day, throughout the week, that's going to identify, that's going to measure to make sure that as we're cutting those, that we are cutting those to 1.5 inches or within the tolerances that we've been given. As those logs or as the boards go into to go cure and dry, we're going to do some quality assurance to make sure that we're drying that to the proper percentage. If that board has to be dried between 8 and 12% moisture content, then we're going to do some measurements and check to make sure that we meet that particular standard. And then finally, on the output, we're going to do some quality assurance to make sure that the overall product, the 2x4, is the exact size and the exact moisture content that it needs to be, or at least within the given tolerance. And you know, a lumber mill is a good example because you know, as you look at 6 different 2x4s, they're all going to be a little bit different. And so we have that tolerance established to say it can be, you know, it can be a little bit warped, it can be a little bit crooked, maybe there's a 1/16 inch of a variation in the thickness or the length, but within that, it fits the standard that is needed. As we do quality assurance, you know, the practices that we use is a sampling practice because it's really not feasible for us to measure or do quality assurance on every single part. If we're at a manufacturing company and we're producing 1,000 parts a day, it's not feasible for us to measure every single one, and it's really not needed. However, maybe it's important that every 100th product or part we're going to take and measure it and make sure that it fits our standards, that it's falling within the tolerances that we've been given. So a sampling is just going to take one of so many and make sure that it's within the standards that we need. So as we go along and we pick the 100th and then the 200th, and let's say we get to the 300th and we measure that one and we're identifying that we are now outside of those tolerances, we have to stop production and we have to make some adjustments on our equipment. Maybe we need to sharpen a blade, we need to change the process a little bit to get that back within that standard. And so it's important at each stage, the input, process, and output, that we do a level of quality assurance on our product. Ultimately, within a business, within a company, within industry, quality is very important. And if our consumers, our customers are realizing that we are not putting out a quality product, then that's certainly going to impact our business, and more than likely we're not going to be in business very long. And so we really have to identify what that level of quality assurance is needed and make sure that we're adhering to that as we provide our service, provide a product to a company. So overall, measurement is incredibly important, and it relates directly to our quality assurance, because as we identify what level of quality we're producing or providing something, we're going to be using some type of measurement to identify if we're meeting within that standard.